Hello everyone and welcome back to physics class. Today we are going to be talking about velocity. Now in the previous video we talked a little bit about position and displacement, and we had asked a couple of questions when we considered these two concepts. We had asked the questions, where are they, or where is the object? Where are they going, or where is the object going? And now I want to ask this question. How fast is the object getting there? Now, velocity is defined as the change in position over time. So, because velocity has displacement in the definition, and we know that displacement is a vector, that means that velocity is also a vector quantity. Because velocity is a vector quantity, that means that there is a direction associated with velocity. This means that you can have a negative velocity. Consider this formula here. Velociraptor is equal to distance raptor over time raptor. Now, this isn't an actual formula, but it helps us to remember what the formula is for velocity a little bit better, because it adds a little bit of humor to it. So whenever I mention the word velocity, I want you to think velociraptor. Really though, the formula for velocity is written like this. V for velocity is equal to delta x over delta t. Now remember, delta x is our displacement. So we can also write it like this. xf minus x naught over tf minus t naught. xf meaning final position, x naught meaning the initial position, tf meaning our final time, and t naught meaning the initial time. So this is our formula that we will be using quite a bit when we are analyzing velocity questions and situations. So let's take an example. A velociraptor moved a total displacement of 70 meters over a period of 25.3 seconds while on a hunt. What was the velocity of the velociraptor? Well, if we remember, velocity is equal to displacement over our time. So if we take 70 meters and we divide that by 25.3 seconds, we would find that our velocity of our velociraptor is 2.8 meters per second. And it's as simple as that. That is, until we start looking at graphs. Now, we can also calculate our velocity based on a position time graph. Now, you have to be careful with this now. You have to make sure that this is a position time graph. You have to make sure of the units, all right? So if you wanted to calculate the velocity of a position time graph, this is where the variant of the formula xf minus x naught over tf minus t naught is extremely useful, because you see this looks very similar to another formula that you should be familiar with, which would be the slope of a line. So velocity on a position time graph is read as the slope. So if we were to just look at this part right here, this sloped line right here, we would say that this is a positive velocity because it has a positive slope, we would say that this here means that there is zero velocity because it's not moving. So we can't measure how fast something's moving if it's not moving. And then finally, this sloping right here, this downward slope, would have a negative velocity. Now, what if we wanted to actually calculate the velocity of a certain... Let's try calculating the positive velocity right here. So I'm going to identify 2 points on this graph. I'm going to identify this point right here, which is 0, 0. And I'm going to identify this point right here, which is 4 and 6. Just bear with me. It's not perfect, but just, we'll go with this. Yeah. So when I have those 2 points, I'm going to now put them into my formula up here. So this becomes 4 is my time. So I have 4 on the bottom. 6 is my position, so that's up here. And since we're measuring in respect to the origin, then the original time and the original position are both 0. So then we would get velocity is equal to 6 over 4, which we can calculate that to be 1.5 meters per second. Let's take a look at another example. So let's take a look at this example. We have this graph here, and we can see that at the beginning, in the beginning 4 seconds, we have a positive velocity, and then in the next 8 seconds, there is no velocity, and then from 8 to 20 seconds, we can see that there's a negative velocity back to the original position of the object. So let's break this up into different sections. Let's calculate the velocity in section 1, which is this one right here. So v1 is equal to our xf minus x naught over tf minus t naught. So let's take a look at our points. So this is my end point. So I have 4 and 6 right here. And then this here is my starting point. So that would be 0 and negative 6. So my final position is 6. And then I'm subtracting my initial position, which is negative 6. And then from here, I have my time. My final time is 4 seconds. And then I'm subtracting my initial time, which is 0 seconds. So in the end, I actually have, when we do this top calculation here, I have 12 over 4, which when divided gives me 3 meters per second. So that is my velocity in my first section. Now we know that in section 2, there's no velocity. So we can say that v2 is equal to 0 meters per second. And you could calculate that using the formula if you really wanted to. But we know that this is a straight line on a position time graph, so velocity is 0. Last, let's calculate this section right here. So v3, I'm going to put that up here. I'm going to identify my starting position, which at this point is 8, 6, and then my final position, which is down here, which is at 20, negative 6. So I'm going to put my numbers in. My final position is negative 6. I'm subtracting 6 from that. And then I have 20, my final time, and I'm subtracting 8 from that. So up here, I ended up with negative 12, and then I end up with 12 on the bottom of my fraction here. When we divide that, we end up with a velocity of negative 1 meters per second for our third portion of the graph. So when I ask you to determine the velocity in each section on a position time graph, this is what I am looking for. Thank you for listening, and I will see you next time when we start talking about velocity time graphs, which are very different from position time graphs.